Hello everyone and welcome to the part 2 of week 8 session on the NPTEL course in pharmacognosy and phytochemistry. We are learning a set of very beautiful compounds that occur in nature, and those are carotenoids. Like we discussed in the previous lecture, carotenoids are compounds which impart yellow to red coloration to the different plant parts as well as the microorganisms. They are located in plastids in plants, and sometimes they might be esterified with fatty acids. In this session, we will see examples of carotene containing drugs such as saffron, marigold and annatto. So if you see saffron is something which is used in culinary and is a very expensive spice. Annatto is something which is used again in culinary as a red to yellow coloration, and marigold is used as an insecticide. But did you know the carotenes of it are very good for the health of your eye. So let's start with saffron. So saffron consists of a flower part that is called as stigma. Now there is a flower called as Crocus sativus which belongs to the Iridaceae family member, and it's an annual plant. It grows in India, especially in the Kashmir regions, in Spain as well as in Iran. So if you go to see, this is a kind of a plant which is generally propagated by means of corm. So this is the image of a corm which is very fibrous, and as you can see it prefers very dry and arid soil. So it grows very specific locations in the world, and the saffron, especially the Indian saffron, is very prized, especially for its carotenoid content and the flavor that it imparts. So what is done is during the monsoon season, that is during the July-August season, these corms are planted. Now they are planted in a raised soil which is well drained, so there is absolutely no waterlogging, and what happens is a year subsequent to that you will find them flowering. So the flowering season of saffron is generally between October to December, and you will see lot of fields of saffron, nice purple flowers. Now these flowers are very delicate, and then they have to be collected very early in the morning, and once they are collected, the stigmas of it are separated. Now the process of collection is done, they are done it in baskets, they collect it, keep or pour all the flowers on a mattress so that they don't turn soggy. Once they have poured it on the mattress, each stigma, each flower has about 3 such stigmas. So each stigma is carefully separated by hand and dried. It is said that in order to get 1 kg of this spice, you might require about 1 lakh flowers or so, and that is the reason this spice is so expensive. Now once the stigmas are separated, they can be dried in a controlled environment like an oven at a lower temperature like 40 to 50 degrees Celsius. In some cases the stigmas are even sun dried. It is very essential that no moisture is retained, otherwise they tend to catch fungus and deteriorate over time. Knowing the price of this spice, it's very valuable, and as a result due care is taken that as much as possible the moisture is removed so that the stigma is maintained. The deep red color of saffron is attributed to a pigment called as crocin. Now this crocin, I am just putting it in your perspective, is an apocarotenoid. As we discussed, apocarotenoids are kind of pigments which are shortened version or abbreviated version of carotenoids. So in this case, let's take for example zeaxanthin. So if you take zeaxanthin and from it again carefully cut over here and here, So I'm just leaving methyl. So 10, 10. What happens in the process is you get an intermediate which is very similar to this. Now you to do one thing is wherever you cut it, just put an O, that is ketone, and then put an alcohol. So this becomes an acid now. Now this is something which is called as crocetin. Crocetin, now to that when you add your sugars, it becomes a glycoside and that is called as crocin. So from zeaxanthin you get what is called as a bi-apocarotenoid. Why? Because two cuts have been made, and from 40 you end up with a compound which is very small like a C20, and a C20 diacid to which your sugars have been esterified is what makes your crocin. Now if you observe carefully, there is one more thing that you will learn in the process is this apocarotenoid, when it is cut, this unit is not wasted. This unit goes to make another molecule which is present in saffron, and that's called as picrocrocin. So if you see carefully, you can see the dimethyl and hydroxy groups. Okay, dimethyl and hydroxy group. In addition to that, you will see this aldehyde group which is here. So you have dimethyl, you have an aldehyde, and you have again methyl. So dimethyl, aldehyde, and again a methyl, and this hydroxy is here. Now it is conjugated with a sugar molecule to get what is called as picrocrocin. Similarly, if you eliminate this and a double bond is induced, you get a compound called as safranal. So that's the beauty of nature. Just take a zeaxanthin molecule, chop off 10 carbons from both ends, add sugars to it, you get your crocin. Now those ends which are chopped off are again converted into O-glycosides to get your picrocrocin, and from that O-glycosides, if those elimination happens by inducing an unsaturation, you get a compound called as safranal. Now all three of this have a slightly different attributes. So the color of saffron, which we saw the deep red color of saffron, or sometimes when you put saffron in the milk or water, you will see that it becomes orangish in color. So that color is attributed to the pigment called as crocin. So this is what gives the color, and this is a apocarotenoid. Now the flavor. Now if you see, or sometimes when you go to buy saffron, people ask you to check the genuineness of saffron by tasting it. Your saffron should taste bitter, and that bitterness is attributed to picrocrocin. The third thing is for saffron, when you use it in cosmetics or any product, or even food for that matter, that is in your culinary, you get a typical aroma of saffron, and that aroma of saffron is due to compound called as safranal. So all in all, one zeaxanthin is sacrificed to give you all three of these compounds, and all three of them have a slightly varied applications and properties. Now where all do you use saffron? Now saffron is, people often put it in their sweets or biryanis, or even numerous culinary purposes have been attributed wherein the aroma and the color imparting properties of saffron have been explored. But in addition to that, now that you know what carotenes are, they are very strong antioxidant compound. Saffron is used nowadays as a sunscreen agent. Now it is also used as an antioxidant, where saffron extracts have been proven to treat, or at least manage the rashes and redness in the face, especially the burning sensation, diminish the blemishes. Now saffron can be added in attars, like I said, that's where you have the aroma properties of it, and to just get a little taste of sophistication, that's added in your western fragrance, western perfumes. Now it is there, it is very mild sweet aroma, but definitely a distinctive one. So these are all the uses of saffron, But yes, being a carotenoid, it can serve all the remaining functions also. But being an apocarotenoid, remember, it cannot give you ionone or retinol nuclease. The reason being is obvious. The retinol part, the cyclic part of your carotenoid is already gone into making picrochrocin, and hence you cannot derive retinol out of it. So this is not a good source of vitamin A, but definitely a very good antioxidant agent. So with that, let's move on to our next drug. Our next drug is a beautiful pigment containing plant called as annatto. Now this annatto consists of dried seeds. In the image you can see the pods. When these pods open up, there are bright red color seeds, and if you take this red color seeds and press it in your hand, you get a lipophilic red color pigment. So lipophilic that it stains your skin instantaneously. In fact, some of the people also call this seeds as, or this plant as, your lipstick plant. So it belongs to the family Bixaceae. It is seen growing predominantly in the South American regions, in the Amazon regions, Brazil, as well as in Caribbean islands, and it's also cultivated in southern parts of India. So this plant is exclusively used for its pigment. So what is done is, this plant generally flowers during the end of monsoons, and within 2 months or 2 to 3 months the fruits are ready. Once the fruits mature, you can see that they develop a nice red seeds inside the capsule. Now this is a tree, so generally the initial flowering starts by second or third year and lasts till 15 to 20 years. So till 15 to 20 years you can continuously get the crop from this plant. So it's very economic also, and when the fruits mature, these are harvested to collect the seeds. The seeds are used for its pigment. Now the seeds contain as high as 4.5 to 5.5% of pigments, which are carotenoids by nature. Now if you see the structure again, you will see that they are not C40. So these are also apocarotenoids, wherein the outer ring is kind of chopped off and you are left with the diacid moiety. Now this pigments, despite being diacids, you can carefully see there are two pigments which predominantly occur in your annatto. The one which is little red in color is your bixin. The one which imparts little yellowish color is your norbixin. Now a little difference between them is this methyl group. So the acid in bixin, one of the acid is methylated. Now because of that acid being methylated, that renders lipophilicity to the molecule, and that becomes more of a lipophilic or an oil soluble molecule, whereas your norbixin, owing to its diacid nature, is easily soluble in water. So what is done is, if I want to separate the oil soluble and water soluble plant, the seeds are taken and soaked in water. The norbixin solubilizes in water, whereas bixin remains attached to the seed. Now this bixin can then be removed or extracted by alkaline extraction. But if you do alkaline extraction over a prolonged period of time, or harsh alkaline extractions, what will happen is, again this ester linkage will hydrolyze. So once the ester linkage hydrolyzes, you will get back your norbixin. So you can get your norbixin from bixin by saponification also. And by saponification, all of this bixin can be converted into your norbixin. Now extraction of annatto-pigment for commerce or for economics, what is used is the annatto-pigment. The whole seed is not used in market. What you get is the crude pigment. So this annatto seeds is subjected to solvent extraction. Like I said, if you want a water soluble pigment, you might soak it in water for some time, wherein all the water soluble pigment, that is your norbixin, comes out. The bixin still remains in the seed. Now that bixin is extracted with organic solvents. Now this organic solvents can be something like your petroleum ether, acetone, or even ethyl acetate. Now they can be from mid polar to non-polar ranges. Once that is done, this is filtered in now what you will get is a deep red color filtrate. Why? Because all your Bixin, which is deep red in color, has now solubilized in that. Now the filter paper will retain the insoluble residue. Now if you use very organic solvents like your petroleum ether to extract it, apart from that, seeds are oleaginous in nature. So apart from your pigments, they'll also have your fatty acids. So these fatty acids are generally precipitated either by concentrating or by using another non-solvents such as acetone. Now once this is done, you can remove the solvent and then the Bixin or the crude Bixin is subjected to crystallization. After crystallization, this is filtered and dried, and this pigment is sold in market as annatto pigment. Okay. It is also sold as your Bixin, but it is not 100% pure. So depending upon the purity, it is labeled as annatto pigment containing. It is standardized to like 90%, 80% and so on, and thereupon you get your different pigments. Now remember that carotene pigments are not heat stable. So anytime you are using a extraction process, you have to be very careful and diligent that you are not using excessive heat, otherwise your carotenes will undergo isomerization. They are all trans, they will get converted into cis, and the next thing that they can undergo is oxidation. So without using much heat, with the mild conditions, all this extraction is done, but in some cases the spray drying processes are also done that gives a quick flash of heat with sudden cooling. Now where do you use annatto? Annatto is chiefly used for food coloring purposes. So if you see your Amul butter, ideally your butters are supposed to be colorless, but that yellowness of butter is imparted by adding some natural colorants, and the natural colorants in your butter, mostly in the case of Amul butter, if you see the package carefully, is annatto. Apart from that, if you want to see cheese, different grades of cheese show different level of yellowness. If you want to see an aged cheese, it has to have more degree of yellowness. So for such purposes where you want to show a little age on the cheese, where you want to show a little yellowness, in that case also for your cheese based products, your annatto is used as dye. In some cases where you want colored rice, in that case also your Norbixin can be used as a pigment. Not only that, like I said, the seed which was used was initially known as a lipstick seed because it imparted a very prominent stain which could not be washed off easily. So it is used in lipsticks and in blushes, and it gives you a nice tint. Annatto is not only just for cosmetics or for food, it also has therapeutic effects, and these therapeutic effects include most of its antioxidant properties. Due to its antioxidant properties, it is good in management of ailments such as diabetes, diarrhea, eye health and some skin problems, especially when you apply it topically. Its antioxidant effect is good for the skin. Now in some cases or some communities, it is seen that they use this seed extract, they kind of press it, get a good extract out of it, and then they mark their bodies with that extract, like body paintings, as a ritual and also as a sunscreen. So this is your annatto. This is something which we see in our cheeses, in our butters, but fail to recognize that there is a natural pigment in there. Now with that, moving on to a plant which is very common to India, and that's your marigold. Now marigold is something we use in our festivities for decoration purposes. Now marigold flowers are flowers of a plant called as Tagetes erecta and belongs to the family Compositae. Now if you have seen the marigold flower, you know that it comes in different hues. Some marigolds are little bright yellow, some are orange, some are even reddish in coloration. So hue of this marigold vary depending upon the variety of Tagetes erecta that you use. The central, you have the South American variety, you have the African variety. it is cultivated in Spain as well as in India. We use it for most of the festivities to make garlands. So it is a part, and there is a reason behind it. The reason why we use this particular flower only in the garland is attributed to its insect repellent activities. The aroma of marigold is known to deter certain species of insects, and that is the reason, along with mango, which is also known to repel insects, the combination of mango and marigold is used in conjunction as an insect repellent garland, which is used in your festivities. So what does this marigold contain? Let's learn that. So chemical composition of marigold, if you go to see in terms of carotene derivatives, it contains xanthophylls. If you remember, xanthophylls are nothing but they are the oxidized versions of carotene. So here what you see is nothing but your alpha and beta carotene, and to that if you attach a hydroxy, you will get your lutein and zeaxanthin. Now in terms of lutein and zeaxanthin, the structure appears almost the same till you see the position of this double bond. Like I said, they are derivatives of alpha and beta carotene, and that's the reason they are just dihydroxy derivatives of alpha beta carotene. Because of their hydroxylation, your alpha beta carotene are red in color, whereas if you see your marigold flowers, they are more of yellow to orange in color, attributing to these two pigments. Now apart from that, you will see your flavonoids, quercetin, rutin, your triterpenoids, essential oils and other compounds. Now the compound which is responsible, I just mentioned, for a mosquito repellent or an insect repellent activity is what is called as alpha terphenyl. Now alpha terphenyl gives you that typical aroma of marigold, which is not favored by many of the insects, and that's how it becomes an insect repellent. Now when you come to your carotene derivatives, your lutein and zeaxanthin are very similar, bearing the position of the double bond, and if you see the molecular weight wise, they are almost identical. Now these two pigments, that is lutein and zeaxanthin, occurs in these flowers as esters. Now what happens is, because you have hydroxy groups, and you know that your carotenes often associate or often stay in the lipophilic regions of the plant. So what happens is, your fatty acids, carboxylic acid group and the hydroxy of your carotene is involved in esterification. Same thing happens here, and what you will get is two fatty acids esterifying with one molecule of lutein and two fatty acids esterifying with one molecule of zeaxanthin. Now once they are esterified, you remember the esterification, if the depending upon the molecular weight of the fatty acid, they become extremely lipophilic and are very difficult to extract. So if I want to extract my lutein or zeaxanthin as compared to extracting your Bixin, which was just a solvent extraction, for extraction of lutein and zeaxanthin, it is always advisable that you treat it with alkali. The moment you treat it with alkali, the ester bonds breaks and you get your free lutein. Okay, and now this free lutein and free zeaxanthin are much easier to purify and separate. So generally, depending upon how the complexation is occur, either for after hydrolysis you get fatty acid and lutein in the ratio of 1:1, or you might get 1 molecule of lutein and 2 molecules of fatty acid. So this is there, and that's the reason while you will see that when industries are preparing lutein extracts, we know that Lutevit, or there are many carotene supplements for which they require the marigold extracts. Now these companies, they generally carry out saponification, they do the extracts in an appropriate solvent and then concentrate the extracts and then load it in their medications. Now because of their pigment, one more interesting application is, if you go to see especially in your poultry industry, when you have your broiler chicken and your country chicken, The eggs of country chicken are very much prized owing to their intense orange color yolk as compared to your broiler chicken, which has about yellowish color yolk. So people associate country chicken with more organic and health, and definitely it is. So what is done is, so broilers are now fed in a diet which is rich in lutein. As a result, what happens is, when the broilers eat enhanced levels of lutein, that somehow through their body passes down to the egg yolk, and as a result the egg of these chickens which have been fed with a lutein rich diet turn out to be orange in color. So that's one application and also a way of fooling market, but that's done, and definitely the higher lutein in your egg yolk is going to benefit you health wise. Now coming to the applications, if you see the applications of lutein in the area near your retina, there is a region called as macula lutea, and this macula lutea not only contains vitamin A, it contains specifically molecules lutein and zeaxanthin. So from your diet, whatever you consume, molecules of lutein and zeaxanthin are taken up by your blood and specifically deposited in the macula lutea region. They are very vital for the functioning of eye, and if this lutein and zeaxanthin molecules are deprived from this region, your macular degeneration starts. So it is very important. They are antioxidant and also help you in perception of color. So what is done is, people those who have poor vision, especially poor color vision, have often been advised to take lutein supplements. Now taking lutein supplements, it has been clinically found out that if you take more and more of your carotenoid based diet, or if you take a supplementation of lutein, the risk of age related macular degeneration decreases. Now this is more particular for elderly people plus 50 also, when your macula starts degrading. You can have your diet which is more rich in your lutein and zeaxanthin to prevent that from happening. Also it is seen that consuming a lutein rich diet decreases the risk of cataract development, which kind of opacifies your lens and you cannot see it clearly. Now there is one more finding which says that if you daily consume more than 2.4 mg of lutein zeaxanthin, there is a significant reduce, or there is a significant decrease in the nuclear lens opacities in such patients. Now coming to the application in terms of veterinary, it is said that people nowadays even prefer carotenoids for their pets. In poultry definitely for the yolk, but for animals for their good health, antioxidant activity, and it is also associated with you know the playfulness or good health of animals. Now Ayurveda also recognizes the significance of this flower, and marigold flower in Ayurveda is reported to possess properties such as carminative, astringent, stomachic. It is used to treat liver problem, fever. The plant is used to treat epileptic fits and even scabies like condition, and this is attributed to, if you see the whole plant, they contain sulfurous compounds or thiophene derivatives. This thiophene derivatives not only kill your microorganisms, they kind of treat you of those infections, and as a result also it is seen that you could use marigold plant extracts as an insecticidal. But moreover, if you focus on the flower part of it, it is very good as far as your health of eye and age related macular degeneration is concerned. So here are a few references if you wish to read more about this beautiful compounds called carotenoids, and thank you everyone for your patient listening.